In this video, we're going to take a look at the stoichiometry study guide. We got all types of questions here, from balancing equations to mole stoichiometry, molar mass to mass stoichiometry, and we even have some limiting reactant questions. So we are going to be saving question 1 for you to complete on your own, and we're going to jump straight to the second question. And this is a balance the equation question. So balance the equation and determine the type of reactant. So the whole thought process behind these is we need the same amount of each element on the reactant side as on the product side. So if I draw a line here, separating my reactants on the left from my products on the right, we got carbon, hydrogen, and oxygen on both sides. And I always like to start with 1, because if you start at the bottom, you could build from there. So when we're thinking about how much of each element we got, you take your coefficient and you multiply it by your subscript. So if I had 1 C2H4, I'd have 1 times 2 carbon, 1 times 4 hydrogen, so 2 and 4. And from the O2, I have 2 oxygen. On my product side, 1 carbon dioxide, 1 C, 2 O's, and 1 water, so 2 H's and 1 O. So from here, I need to change my coefficients to make sure each of my elements are the same on both sides. A strategy here would be looking at my right side and noticing both of these have oxygen. So oxygen should probably get matched last. That would be a good strategy. So let's start with carbon since it's on top. So we got 2 on our reactant side. We only got 1 on the product side. So we need more here. And if I look at which of these molecules has carbon, it's the carbon dioxide. So if I just add 1, I go from 1 to 2. So if I'm going up by 1 coefficient, I would have to add 1 carbon, and I'd have to add 2 more oxygen. So there we go. And from that, look, my carbon is now balanced. So I know I'm going on the right track. If I look at my hydrogen, I have 4 on my reactant side, 2 on my product side. I need more on my right side. And I know I can add 2 if I add 1 more water. So I'm going to change this from a 1 to a 2. And when I move that up 1, I have to add 2 hydrogen, and I also have to add 1 oxygen. So everything's balanced now except my oxygen. I got 2 carbon on both sides, 2 hydrogen on both sides. I need more oxygen here. So every time I increase this by 1, if I go from 1 to 2, I would have to add 2 oxygen. So I'm still short on my reactant side by 2, so I just have to add 1 more. So I'd move up to 3 now. There we go. And we got a nice balanced equation with all these coefficients. These are going to be very useful in the following question. So B says, if you react 4 moles of C2H4, how many moles of O2 would react? So we could write that down. We're given this number, 4 moles C2H4. And our balanced equation up here is written in moles. All these are moles. 1 mole of C2H4 plus 3 moles of O2 would react to make 2 moles of CO2 and 2 moles of H2O. So if I'm comparing my C2H4 with O2, I'm starting with C2H4, so it goes on bottom. And my O2 is what I'm trying to find, so that goes up top. And I plug in my coefficients. So what this means is for every 1 C2H4 I use, I'm going to need to use 3 O2s. When I do the math, 4 times 3 divided by 1, that would be 12 moles of O2. When I'm finding my molar mass, I got to use a periodic table here. I'm just going to round. All my masses are these numbers down here with all the decimals. I'm just going to round to the nearest whole number. So in C2H4, I have 2 carbon. They each weigh 12 grams for a mass contribution of 24. And 4 hydrogen, they each weigh about 1 gram for a mass contribution of 4. So that would be 28 grams per mole. Oxygen, we got oxygen has, let me put a circle around this. Oxygen has a molar mass of 16. So if we have O2, that's 2 oxygen, it would be 2 times 16, or 32 grams per mole. And moving on to this next question, we got carbon dioxide. It's just O2 with a carbon. So we just said O2 was 32, and carbon weighs 12 more grams per mole. So that'd be 32 plus 12, or 44 grams per mole. And over here we got water. So water is 2 hydrogen. They each weigh 1 gram for a mass contribution of 2. And that 1 oxygen, which we just said weighed 16 grams for a mass contribution of 16. And we have to add all the masses together. So 18 grams per mole. So I'm hoping that's a review. But if not, that's kind of the way we would solve it. Question D. If you reacted 96 grams of oxygen, O2, how many grams of H2O would be produced? So when we get a mass to mass stoichiometry problem, we got to think, in order to use our balanced equation, the first thing we have to do is convert to moles. So I'm going to write here, we got 96 grams of oxygen. And my first step is to convert to moles. And in order to do that, 1 mole is equal to 32 grams. And that's why it's important to have our molar masses. If I divide this, 96 divided by 32, I would get 3 moles of oxygen. And now I have moles. I can use this balanced equation up here. So what I'm going to do is I plug in what I'm starting with on the bottom, O2, and what I'm looking for, H2O, that goes up top. So 2 for the H2O straight from here. For oxygen, we got 3. So it would be 3 times 2 divided by 3. And the reason these numbers are used, we could think of it as being, for every 3 oxygen we use, we're going to be making 2 water. So 3 times 2 divided by 3, that would equal, and we'll move that down here, 2 moles of water. So if I was asking for moles of water, I'd be done. But I'm looking for how many grams of water. So it's a simple conversion now. I have moles, and I just have to multiply. I know 1 mole is 18 grams. So I just have to multiply by 18 grams. And I get 36 grams of water. The last 3 questions are all kind of connected. They're all limiting reactant questions. So we're thinking, if we go back to our chem lab and we got 56 grams of C2H4 and we have 96 grams of O2, what is our limiting reactant? So if you pick correct, excellent, it shortens your question. But if you pick wrong, it's a little bit longer, and that's okay. So we're just going to randomly pick 96 grams of O2. We might run out of that first. So what we would do is we would take that number, 96 grams of O2, and we have to compare it with how much C2H4 we would use if we used all 96 grams of that O2. So it's just like this problem above. I have to convert to moles first. So what we'll do is, I know 1 mole of O2 is 32 grams. So 96 divided by 32 is 3 moles of O2. And then I want to see, if I use 3 moles of O2, how much C2H4 am I going to use? So I'm going to have to use my balanced equation way up here. So let's write it out here. So O2 goes on the bottom, C2H4 goes up top. So 3 and 1. So for every 3 O2, I would use 1 C2H4. So 3 times 1 divided by 3, that would equal 1 mole of C2H4. And then I would just have to convert it back to grams because I got to compare it to that. So I got my molar mass right here, 28 grams per mole. So I would multiply that by 28 grams per 1 mole, or 28 grams of C2H4. I now have to interpret this information. So if I used all of my oxygen here, all 96 grams, I would use 28 grams of C2H4. So I got to think, what is my limiting? And so the way I would think about it is, do I have this much? Do I have 28 grams of C2H4? And the answer is yes, I got 56 grams. And I would even have extra C2H4. So C2H4 is my excess reactant, and 96 grams of O2 is my limiting reactant. So limiting reactant is O2. So I got really lucky there. So now that I know my limiting reactant is O2, I would have to use 96 grams of O2 when I wanted to calculate how much of any product we would make. So when the next question says, how many grams of carbon dioxide would you be able to make with the amount of limiting reactant? I am going to start with 96 grams of O2. If I had found that my limiting reactant was C2H4, I would have to use 56 grams of C2H4. So whatever our limiting reactant is, that's what's going to help us figure out how much product we can make. So, excuse me. Now that we know our limiting reactant, we can compare this with carbon dioxide. So our first step, and we've done this already here, is figure out how many moles we got. So we'll just write this out. It's 3 moles of O2. From there, I'm comparing O2 with carbon dioxide. So we know if 3 moles of O2 react, we're going to get 2 moles of carbon dioxide. So we could fill those in. 3, 2, carbon dioxide. 3 times 2 divided by 3, that is going to be 2. 2 moles CO2. And from here, all I got to do is calculate to grams because I need grams of carbon dioxide. So from moles to grams, we know 1 mole of carbon dioxide is equal to 44 grams. So we got to multiply by that. And our answer, 88 grams of CO2. So this last question, how much of your excess reactant would you have left over? We got really lucky there. So our excess reactant is C2H4. So we know we started with 56 grams. And we know if we used, let me make this clear again. We know if we used all of our oxygen, we would have used 28 grams of C2H4. So if we started with 56 grams, and let me write our units here, C2H4, and we used 28 grams of C2H4, we will have 56 minus 28 is 28 grams C2H4 extra. If we had used 56 grams of C2H4 here and calculated how much O2 we would use, we would have to go back and solve it this way down here. So this step, this question isn't always that short. Sometimes we have to do a mass to mass stoichiometry there if we don't pick our limiting reactant correct. So I hope this video makes this a little bit easier. I know these steps can be confusing when all put together, but if we remember the main ideas here, we're always trying to do our stoichiometry with our balanced equation in moles, and that's the only reason we have to add those extra steps to go from grams to moles or moles to grams. That's where a lot of the extra work comes in. So I'm hoping this helped us out.